Hi guys, welcome back to the channel. Today we'll be diving into SQL or Structured Query Language. Well, what is SQL? SQL or Structured Query Language is the official language which is used to interact with the relational databases. What are relational databases? Relational databases basically store data in tables such as spreadsheets, but with certain relationships which have been established across tables with the help of keys like primary keys, foreign keys and more. Each of the tables basically holds a structured values present within rows and columns, where each row is a record and each column is a field. SQL therefore allows you to define these tables, add data to them, make the changes, ask queries about the data, and even control access to the data in a large administrative setting. But why is it called structured query language? Well, as we just talked, data is stored within structured formats within tables, and they have predefined columns and rows. SQL works only on this kind of a structure, and it usually does not work well when we are talking about data which is unstructured in the form of PDFs, videos or raw images. SQL is not a programming language, it's a data language. Unlike Python, Java or C++, SQL does not implement loops, if-else logics or an object-oriented programming approach. SQL is just a declarative language which we involve you say what you get, not how you get it. As one of the saying goes, this is a huge deal as it basically allows us to use SQL in simple, short and readable format, unlike most programming languages. Let us take an example of a real life scenario whereby which SQL as the only language where the librarian understands. Let's say you walk into a national library, you roam the aisles. Instead, whenever you approach the librarian, you ask her or him or her, I want all the mystery novels by a so-called author, let's say Agatha Christie. But here you should always speak in a specific syntax. The syntax is defined by SQL. The librarian here is our database engine who understands the SQL syntax. It processes this query and hands you the perfect list. The key point here is that SQL isn't the librarian, it's the language that gives instructions to the librarian. The engines, which are like MySQL, PostgreSQL or any other platform. In SQL, we basically can perform different everyday actions such as select, insert, update and delete. Let's say we ask the librarian to get hold of a book. We would write something like select star from books where the publisher year is 2023 or whatever depending on your requirement. Here we have basically performed an SQL contemporary of the same particular action which we expect from the librarian. Let's say you are trying to insert or add a new collection of books to your library. In that scenario, we would basically perform an insert action on our database. Similarly, if certain details associated with the book are needed to be edited, such as updating the author name, we go ahead and write the update command. Similarly, certain outdated books or versions may need to be removed. Under that scenario, you go ahead and write the delete statement. For this aspect to be performed in SQL, there are 4 core functionalities or languages which are part of SQL within itself, which are DDL, Data Definition Language, DML, Data Manipulation Language, DQL, Data Query Language, and DCL or DCL as whatever you want to call it, as Transaction Control Language or Data Control Language. These are the different 4 pillars of SQL which basically allows you to perform CRUD operations As we already know, SQL is a declarative language which is involved in the process of interacting with relational databases. All these languages or sub-languages within SQL or core functionalities or whatever you want to call it, they allow us to perform create, read, update and delete data, or they are also known as CRUD operations. SQL therefore is able to directly talk to the database engine, execute your requests and perform your required action that you are expecting the SQL engine to do. So yeah, let us try to now jump into some of the basic commands which are possible to be performed within SQL. Let's say we are now, one other thing before we move on, in context of the library scenario, how would this really look like? Let's say in terms of manipulation, you would like to add certain books to the existing library records. It would look somewhat like a librarian adding new books to the collection, while data query language would look like somewhat where we request the librarian to get hold of a specific version of a book or a collection or whatever the user requests. The DCL or the data control language, it usually looks at the administrative aspects whereby which certain sections would not be allowed, or certain places within the library are restricted where access is only granted to specific members. This is more of like an administrative task, and that is also possible to be done in SQL. Let's say, or let's just recap the four core functionalities and what they perform. Data definition language's purpose involves defining the schema of the table. It uses different commands such as create, alter and drop. It usually does not affect the data, but it does affect the schema or the structure of the table. Data manipulation language involves modification of the data present within the table. It involves inserting and updating the data. It does affect the data, but usually there is no structural schematic changes to the table. While data query language involves querying or reading specific type of information of the table, this does not involve any changes to the structure or the schema of the table. Similarly, data control or transaction control language involves granting permissions to certain users, maintaining rollback and saving changes. It does change the data, however schematic structure of the table again is not affected. Let us try to talk about this all aspect in context of a hypothetical table that we were just talking about, which is the library. In this case we will define a sample table which replicates this library situation. Let's say it has an ID column, a title column, an author column, published year and genre. The ID is the primary key here, which is able to uniquely identify each of the rows and each of the elements which are present within this library, which involves the books and their associated authors, the published year and the genre into which they fall into. Let us try to perform some of these basic SQL queries that you will encounter down the line whenever you are working with SQL. The first case is, let's say we want to involve ourselves in wanting to list all the books within our table. Therefore, in that case we will go ahead and write select star from books. This does exactly what it sounds. The asterisk symbol basically refers to all the columns. We basically get every book's ID, title, author, year and the genre. The second command basically involves us to narrow things down a little bit. Let's say instead of viewing all the data, we want to only retrieve the title and the author of the books that are in the science fiction genre and that have been published after the year 2010. Here we basically use a special clause called the where clause, which allows us to filter out the data based on these set parameters. Therefore, once you have understood these requirements, once you go ahead and write the command would look something like this. Select title, author from books, where the genre equals to science fiction and the published year is greater than 2010. Remember that we are only interested in listing out the title, the authors of all the sci-fi books which have been published after 2010. In order to satisfy this requirement, you would see that we basically use the AND clause, which involves us to return true statements for both the conditions that we are setting up and all the rows or all the elements which are present within our table which satisfy this requirement. They are identified and then they are listed out as the result. Moving on, let's assume that we would like to add a new popular book called The Dune with an ID 1. In order to insert this kind of a book into our database, we will go ahead and we use the insert into command. Here we are adding the book Dune with its ID, author, publication year and genre. Let's say or think of it as filling a new row on the spreadsheet. So once we have identified the requirements, we will go ahead and write something like insert into books. The attributes, you always need to remember that whenever you specify the attributes, the order of the attributes has to be consistent with the schematic structure of the table, beginning with the ID, followed by the title, the author, published year and genre. Once this has been defined, we will go ahead and insert the values 1, which corresponds to the ID, the title of the book, which is Dune, the author, who is Frank Herbert, the year 1965, followed by the genre, which is science fiction. However, let's say you just made a mistake. We just got the author's name wrong, or let's say slight variation has been found which is more accurate compared to the data that we just inserted. In order to update the author of the book with the ID 1, we will go ahead and use the update command. This would correct the author for the book with the ID 1. We also notice the use of the where clause. Always remember, if you lose or fail to use the where clause, it would accidentally change the authors for all the rest of the rows within the table. So here, once we have identified the requirements, we will go ahead and write update books, set the author to Franklin Herbert, where the ID is equal to 1. This would effectively change the author's name from Frank Herbert to Franklin Herbert, since the values have been identified by our primary value, which is the ID. Always note, do not ever forget the where clause. This is the wrong implementation of the same command. If we go ahead and write update books set author equals to Franklin Herbert, this would cause an issue whereby which it would update all the rows, and this would be erroneous since every book would end up with the same author. So always be careful whenever you are using such kind of update commands. If you forget the where clause, always be ready to live with the consequences. Usually this is not a good practice, so always note whenever you are trying to manipulate data, always double check, always go with the where clause. Similarly, let's say we would like to delete the book with the ID 1. Let's say in this case the specific book which has the ID 1 needs to be removed. Therefore here we would use the delete command. This command would target only the row where the book's ID is 1. Again, the where clause ensures that we only delete that book that we want. So here we will write delete from books where ID equals to 1. As before, remember that whenever you write delete, update, any of these commands, you should always specify the where clause, as without it would just delete all the values which are present within the table, and that is not something that we want to do. Let's move on to the next command, which is, let's say we would like to guess or see how many books are there which exist per genre. If we want to group our books by genre and count how many of them exist, we will have to use another clause called the group by clause. The group by clause basically groups similar genres together, and the count star tells us how many books fall under each. So once we have understood the requirement, we will go ahead and write select genre count star as book count. Here the values which have been found out would be listed under book count, and that is our user defined name that we are providing over here as book count from the table books, and then group by genre. Moving on, in order to define or design the table that we were working on, as of the moment, we would go ahead and define this under the command structure somewhat like this. In order to create such a table where the books need to be listed or stored, we use this command to create the table books and define the columns along with their data types. The data types basically have to be consistent with the data that is being stored, such as ID being number, and therefore we will go ahead with the data type integer. The title being characters, therefore we go ahead with varchar. This is true for author and the genre as well. The published here is optional. You can go ahead with ID or date time depending on your requirement, which suits the data the most. And therefore you would go ahead and execute this command to basically create an empty table. Let's say you want to add a new column for the user's ratings. Whenever you want to store a user rating like 4.5 stars or 3.8 stars, we would like to alter the schematic structure of the table. Here we would go ahead and write alter table to modify the existing structure. The new rating column basically uses decimal 2,1. This allows us to use one decimal place, such as to represent the numbers 4.5 and 3.8. Therefore, once we have understood the requirements, you can go ahead and write this specific command alter table books, add the column rating decimal 2,1. Note, depending on the requirement, let's say if you want to have two numbers before the decimal place, you will write something like 3,1 and so on. In order to drop the table, be careful with this one. This would delete the entire table. For this, you would use something like drop table. All the structure and all the data would be removed. This is equivalent to deleting a file. There is no going back unless you have a backup. So, drop table books. Always remember, whenever you use any of these commands which comes to manipulation, deletion or alteration, always double check what you are trying to execute. Let's go ahead and insert a record to our table. In order to insert a record, here's another example. Let's say we just found another book called Atomic Habits, and we would like to insert this new book to our table. Remember that the values have to be consistent with the schematic attribute structure and order of the table that we are working with. Therefore, you would go ahead and populate these values accordingly. So it would be having an ID 4, the title of the book, which is Atomic Habits, the author, followed by the year, and the genre. Let's say we just added this new row and populated these values into our table, and we just found out that we would like to update the genre to a new category called productivity. So for that, we would go ahead and use the update command. Here we are going to be updating the genre of Atomic Habits to something more specific called productivity, and we use the primary key, the ID, to target these changes. Therefore, once we have understood these requirements, we'll go ahead and write update book set genre equals to productivity, where the ID equals to 4. In order to delete a record by the Title, always remember that when you go with some of these very specific attributes such as the title, remember that the text has to be consistent with the text which is present within the table, else this command would fail. Let's say we would like to delete this book, and instead of using the ID we are using the title. We can do that too. We just match the title in the where clause and run the delete command. So we will write something like delete from books where title equals to atomic habits. Once all the changes have been done and you would like to see how the books table looks right now, you will go ahead and write this command select star from books. This will get everything from the books table. Just like we repeated this in our very first query, you will get the list of all the books again. This is a useful way to check what's in the table after all the manipulation, addition and deletion and updatation. So yeah, let's say we would like to again perform the filtered search. As before, you would write select title author from books where genre is equal to fiction and published year is about older than or after 2010. You can also perform a group by an aggregated command execution whereby which you would like to group by genre, but this time you are also calling the count column total books instead of book count. So SQL will allow you to rename the columns with the help of the as particular keyword for better readability. Similar to this, if you remember, we are now going to talk about the DQL, the TCL and the DCL aspect, which is the data control and the transaction control languages. These languages or these permissions basically grant limited access to users who are using the database. In a real system, we would like to control who would have access to what and what actions that they can perform. This is a hypothetical scenario where the user is named as librarian underscore user, and the permission here we would like to grant to this particular user is to view and add books, but not to delete anything. This would prevent any accidental data loss and therefore maintain a sense of order. So this is how the command would look like. Grant the actions select insert on the table books for the user to librarian user. So this is one of the ways where we control the transaction across tables. So yeah, lastly we can talk about safe transactions. Let's say in order to maintain a level of safety, we will go ahead and write begin before we start the transaction. If you realize something has gone wrong, let's say we deleted too many books, and then we would like to roll back or cancel these changes, we will go ahead and write the rollback command. And once you are done with this, you would like to change once you are satisfied with your changes, you would like to, let's say, commit or save these changes, you will go ahead and write the commit command. So here, as you can see, we are going to write begin, and in this scenario, let's say we would like to delete all the books which are now under the category of outdated genre. And let's say once you are satisfied with these changes, instead of rollback you will write commit followed by the semicolon. However, let's say in that case too many books were lost or too much data was lost, and this is not consistent. So in that scenario you will go ahead and write the rollback statement. So yeah, that's pretty much all the different kinds of commands that are possible. This is more of a theoretical approach to this problem that we are going to be delving into SQL, and in the following videos we will dive deeper. Before I move ahead, I think we would like to also know about the standardized dialects of SQL. Before we go ahead, you can see the different the command structures which are popularly used across different SQL platforms. This is in MySQL. You can see this is one of the data definition commands, which is defining a table called test results. It basically has the attributes, the name, student ID, the birth date, the result on the test, the grades, and whether the particular student, he or she, has passed a particular subject or not. So this gives you a pretty good idea about how the structure of the command usually looks like. It involves parentheses within which the attributes are defined. Each of the attributes start off on a new line, and they are always separated by commas with after the particular data type has been specified. Usually the data type and the attribute term are usually separated by tabs, and they always close with a parenthesis and end with a semicolon. Similar to this, in PostgreSQL, which is another SQL platform, to perform the insert action, you would go ahead with this similar activity, whereby which there is a slight variation. This is exactly what I was talking about when we were discussing the SQL dialects. We'll dive into this a little bit more in depth. And let's say we would like to retrieve all the employee data in an ordered fashion, in ascending order. Even that kind of an action can be performed in SQL. This is another one of those screenshots which talks about updating the values within the table. Let's say in this case we are updating the particular employee's first name, last name and birth date, as well as gender. We identify this user based on their particular primary key, which here in this case is an employee number, which we have to accurately specify. So yeah, these are the different forms of SQL. As I just mentioned before, SQL is standardized to most extent. However, there are dialects which are available. SQL is a universal language, but it has its own accents. Let's say whenever you are looking into systems like MySQL, PostgreSQL, SQL Server or Oracle, you'll notice these subtle changes, and that can be frustrating. We would like to talk about what is essential for learners when we go ahead and start learning SQL, in order to be able to accommodate portable SQL commands and avoid these common frustrations and pitfalls. Usually SQL in the earlier days was defined by the American National Standards Institute in 1986 in order to define SQL and unify how databases interact with databases. That holds mostly true to some extent, but nowadays, because of multiple vendors, they like to add their own flavor to it. Let's say, in order to give you a better analogy, SQL ANSI was the recipe, and each of the DBMS or database management systems out there just went ahead and added their own twist, and this has created to some extent a large variation, slight variations you can say, across these platforms. Let's say we want to add let's say in this case we would like to only list the first 10 rows or few rows of a table, and in this case when we go ahead and perform the same action across different platforms, the command slightly varies. So let's say in MySQL you will go ahead and write something like select star from books, and here we would like to limit ourselves to the 10 results, so we will write something like limit 10. But under SQL Server there is an entirely different structure or syntactical nature which is being followed, which will look something like this: select top 10 star from the books. While under Oracle it is somewhat similar to MySQL, but they basically focus on row num, so it would look something like select star from books, where row num is less than or equal to 10. This is not only limited to limiting ourselves to results, it also bleeds into other aspects, such as let's say we would like to automatically increase the ID values as the number of rows are getting incremented. That also auto increment feature is defined in a different way depending on the syntactical nature across these platforms. So it would look like create table books ID followed by the data type. Since we would like to auto increment, we will write auto increment followed by primary key, so whatever, this is the definition depending on the user's requirement. That is how it would look like. But the same case can't be said across different platforms. You can see that the command basically varies. I hope you understood what I was trying to deliver on. You do not have to memorize or learn any of this. This is just driving home a point that SQL, though is a universal language, there are slight differences that you would encounter depending on the platform that you will be diving into. So, most importantly, what is the use of SQL? Well, it is used almost everywhere in modern systems, from startups to tech giants. Whenever it comes across important aspects such as making decisions or making automation, all of this requires SQL. So, I hope that makes sense. And yes, finally, as a breather, as a summary, SQL basically is a structured query language. It's mostly declarative, which means that you tell the database what you want and not how you do it. And yeah, it is being used almost everywhere, from websites, apps, data warehouses, finance systems, and more. And yeah, mastering SQL will basically open up your career options to multiple fields, and therefore it's one of those things that you should know if you are going out into the real world. I hope you got something from this. This is just an introduction. We will dive into further concepts and commands and DML, DQL, TCLs, and more. And yeah, I hope I did not bore you with this theory, and we will meet each other in the next one. Bye.